Hello students, this is SAHA tutorial and today I discuss about a very important topic from differential calculus. This is Rolle's theorem. So before starting this topic, I appeal to all of you to subscribe this channel. After subscribing this channel, you will get all these videos. Must subscribe, and if you like this video, then like, comment me, and of course share it with your friends. So let's start. First, I state Rolle's theorem, then I will discuss this topic. So, I am first stating what is Rolle's theorem. If you understand, then it is very easy to remember. If you very easily understand, then even you can very easily also remember this Rolle's theorem. There are certain conditions for Rolle's theorem. First condition is that we have a function. We have a function fx. First, fx is a function, such a function which is continuous, means continuous in a closed interval, in a closed interval, interval AB. So AB, in AB, and the function fx must be continuous. There will be no discontinuity. Second condition is that the first derivative of f must exist, must exist in the upper interval, in the upper interval, open interval EB for all of the points between EB, for all the points, for all the points of X lying in this interval EB. The two conditions I already said. Also, the third condition is that if this is third condition, if A at the point A the value of fx and the value of fx at the point b must be equal, then these three conditions 1, 2, 3 if satisfied, then we can say that then there exists at least there is at least one point one point between or in the interval or in the interval one point in the interval AB interval AB that for which for which say this the one this point is x slash we are taking that this point is x slash. So for this for this there is a one point in the interval x slash say. So for this the derivative of fx at the point x slash must be equal to 0. This is the Rolle's theorem. True or not, and how the Rolle's theorem I am now discussing. So let's see. I am taking a graph first. A Cartesian plot I am taking. I am taking two intervals. This is E0. This is E0. E is negative, and there I am taking another point B0. B is positive. Now, if we draw, we have to find out the first condition was that f must be continuous fx. Second condition is that first derivative of x must exist, and third condition is that fa must be equal to ab. So marking this, we have to take fa at the point fa and fb. If we equal here, you can look this. What is the value of fa? This is fa. Then fb must be equal. Here fb is must be equal. So what is fa and fb is equal, and the whole function fx y equal to fx is continuous. There is no discontinuity in this closed interval. And first derivative of a of ax is also exists because this is fully continuous, and in the closed interval you can look this, there is no discontinuity. First derivative of ax must exist in this open interval. So we get a point for x where first derivative of the uh, function is equal to 0. So if you know the supremum or minima, maxima or minima, if you know for maxima or minima, uh, for any curve, for for any curve between in a closed interval or any interval, um, have a maxima or minima if the first derivative at that point is equal to 0. So we must have in a interval there must be a minima or maxima. So you can look this, there is a minima and there is a maxima. So there is also a minima. So this kind of minima or maxima for different values, like here it is I am taking x1, here must be first derivative of x1 is equal to 0. So this is the Rolle's theorem, x1 is equal to 0. For maxima here, where the curve take the peak value, or yes, where the curve takes peak's value is called maxima or minima. So and according to as we know from the maximum minimum rule that at the point of peak point must be the first derivative is 0, and there's the Rolle's theorem, x2 is equal to 0. Here again if you will take x3, then here also we'll get that. So we are getting 3 points here. So Rolle's theorem says that at least 1 point we must get. If FA and AB are equal, so it must be that there will be a maximum or minimum. Because if we show in another picture, because fx is continuous, if we will take two are same, 2 points are same, FA and FB, this is A and this is FA, this is B, so this is FB. If 2 points are same, then fx can be either in this way, at least 1 point you will must find. So here you are looking this, that this is the minima, so there must this point must be at this point must be this is 0. Or if you take the constant function, so here since f dash is f dash uh, x exists, uh, f dash x exists, so here also say if x is equal to c constant, then at each of the point this will be 0. So if this is constant 1, then also you have a every point here on this graph from here to here, each point are satisfying Rolle's theorem. And if the graph is in another way, then also if the graph is in this way, if this graph is in this way, then also we have a peak point and Rolle's theorem is satisfied at this point. There are many. If you take fa and fb equal first derivative of x exists and fx is continuous, then there must you get at least one point where the first derivative of the function is 0. So it is true, but one is contradictory. Example also, that if this condition is true, then if then so by the analysis it is found that Rolle's theorem is true. Rolle's theorem is necessary condition, not the sufficient condition, not the necessary condition. Rolle's theorem is sufficient. The converse is not true. That this is sufficient, not necessary. Means the converse is not true. If we will satisfy converse is not true, then I will give an example that the converse is not true. Why I am saying the converse is not true? That's an example. Here I am taking an example fx is equal to 1 by x plus 1 by 2 minus x. So it is very easy to find out that it is continuous. It is continuous. It is continuous in the closed interval 0 to 0 to 2. It is closed interval. It is continuous. And also in the open interval 0 to, the first derivative of fx exists. If this exists, the open interval x exists. So these are very easy to check out. Now, if we find out what is the first derivative of x, then it will be if we differentiate it, then it will be minus 1 by x square. This will be minus plus equal will be 2 minus 2 minus x whole square. So what is the important thing? If you will take x equal to 1, then it will be minus 1 and this will be plus 1. We will take x equal to 1. So in this point x equal to 1, this is what you will find out at the point f first derivative of f1 is equal to 0. So according to the Rolle's converse theorem, f0 must be equal to f2. But if you look this function at the 0 and the 2 point, this is undefined. You cannot say that converse of the Rolle's theorem is always true, because at the point 0 and at the point 2, the full function is undefined. It is undefined. So you cannot say these are equal. So sufficient condition that if uh, two functions are equal at in the end point of the interval and continuous and first derivative also exists, then you must get a point where the first derivative is 0. This is true. This is sufficient. But the converse is not true. This is the example. So I hope you like this video. If you like, then like, and if you have any comment, then comment me. And if you have not subscribed this channel, so subscribe this channel. So let's continue watch for today. Thanks for watching.